Let's learn a few more properties of triangles. We'll start with the isosceles triangle property. In a triangle, if any two sides are equal, then the angles opposite to them are also equal. Let's consider this triangle ABC. Since this is an isosceles triangle, we'll have AB is equal to AC. The property says that the angles opposite to these two equal sides are equal. So, angle B is equal to angle C. Let's prove this. To do that, let's mark the midpoint of the side BC. Let this point be X. So, BX and XC are equal. Now, let's draw AX. Considering the triangles ABX and ACX, we have AB is equal to AC since it is an isosceles triangle. BX is equal to XC. This is because X is the midpoint of BC. We also have AX, which is a common side. So, according to SSS congruence property, we can say that these two triangles are congruent to each other. And that means the corresponding angles ABX and ACX are both equal. In other terms, angle B is equal to angle C. Thus, we have proved the property. Now, let's move on to the next property. Angle opposite to the longer side is always the larger angle. To understand this property, let's draw a triangle ABC in which the side AB is greater than the side AC. The property states that the angle opposite to the longer side is the larger angle. So, angle C is greater than angle B. Now, let's prove this. To do that, we'll mark a point X on the side AB in such a way that AX is equal to AC. Now, we'll join X and C. The triangle thus formed AXC is an isosceles triangle. So, we can say that angle AXC is equal to angle ACX. Now, this angle AXC is an exterior angle of the triangle XBC. So, this angle can be expressed as the sum of the two opposite interior angles, which is angle B plus angle BCX. Here if you note carefully, since angle AXC is the sum of these two angles, it should definitely be greater than each of these angles, which means we can conclude that angle AXC is greater than angle B. And because angle AXC and angle ACX are both equal, we can write that angle ACX is also greater than angle B. Now, let's consider the angle at point C. We can say that angle C is larger than angle ACX. Now, combining these two inequalities, we have angle C is greater than angle ACX, which in turn is greater than angle B. And that also means that angle C is greater than angle B. Thus, we can prove our property. With that, we move on to the next property. The sum of any two sides is always greater than the third side. Considering the triangle ABC, if you add the sides AB and AC, it should always be greater than the third side BC. To prove this, let's mark a point X on the side BC in such a way that the line AX is perpendicular to the side BC. Now we have two right triangles. Let's remember, in a right triangle, the hypotenuse is always the largest side. So, in the triangle ABX, AB is the hypotenuse, and hence we can say that AB is greater than BX. Let's name this as 1. Similarly, in triangle AXC, the side AC is greater than the side XC. Let's mark this as 2. Now, let's add these two inequalities. AB plus AC is greater than BX plus XC. Here, we can say that BX plus XC is nothing but the side BC. So, our inequality becomes AB plus AC is greater than BC, and thus we have proved the property. With that, we move on to our last property. A right triangle can never be an equilateral triangle. The proof is very simple. In an equilateral triangle, all the three sides and all the three angles are equal. We also know that the sum of the angles in a triangle is 180 degrees. That means each of the angles should be 60 degrees only. Hence, an equilateral triangle can never be a right triangle, and also a right triangle can never be an equilateral triangle.